Hopefully this is recording. I don't know, we'll find out in a second. All right, so as we go through this, we are talking about segment addition, and it's the same thing that we did last week. It's just that there is algebra. So the distance between 2 points A and B can be written as length of AB with a line, or just AB. That's all we're doing. So this first little bit is a review of what we did the first time we took notes. We're just reviewing the vocabulary, how we write it. And how the vocabulary is and the sequence is. So if I tell you that AB is equal to BC, sorry, that's not what it says, CD, if I tell you that those two things are equal, then that's, remember what it means to be congruent. Equal has to do with measure, and congruent has to do with their size. We talked about how donuts can be the same price but be different sizes. And so that's what the difference between equal and congruent. And so this is written as AB is congruent to CD. So congruent is this symbol. Not that you can see that. It's an equal sign with a little squiggle on top. That's what congruent means. And so we use that all the time. So you're going to see it's important, just like when we were doing inequalities, like those two things are not the same. And so we need to be specific about the symbols that we use so that people understand what we're trying to say. We talked about the segment addition postulate and how the definition sometimes is easier once you draw the picture. So if A, B, and C are collinear, same line, so we know they're on the same line, and B is in between, then we know that AB plus BC equals AC. So that's all we're saying, is that those things together, those two pieces do equal that. As we go through this class, you're asked to justify the steps that you take. Why can you say that's true? And you would say, well, the segment addition postulate. Or if you say, don't write this down, but if we have -3 plus x equals 5, and we add 3 to both sides, that's the addition property. That's what that's called. The addition property of equality is what lets me do that. I can't do it just because. I have to have a reason. So as we justify, that's what we're doing. So Thursday, we did just numbers. And that's kind of going to be the pattern of geometry this year. We're going to do the first couple of levels with just numbers to get you used to it. And then we throw some expressions in there with x so that you have to use algebra. So for the first one, when I draw this out, if Q is in between, P, Q, R, QR is 28 and PQ is 9. That means PQ plus QR equals PR. I want you to get in the habit of writing that sentence. It helps you know where to substitute. If you're making mistakes, it's because you don't understand where to substitute, because you didn't write the equation to start with. Once you do that, like, what is PQ? Right there. So I know that that goes there. And what is QR? Right there. And PR? Well, that's what I don't know, so that makes it X. So then we do 9 plus 28 equals X. 37 equals X, which is equal to PR. So having that sentence there makes it clear what we're looking for and where I substitute those numbers.
Is that an 8 or an F?
It's an 8. Here? Where?
Next to the 2.
There's two 2s. This one or this one?
Both of them.
Seriously?
It looks like an ash.
Oops, that was too big. 28. Happy?
Yeah.
All right, okay. The most common mistake I've seen with students when they do these two problems, 1 and 2, is that they add when they should subtract and vice versa. How do you know when to do which? When you write it down. So as soon as I draw my picture, and I know that it's P and Q and R, and I know that because it's going here. So QR is 17 and PR is 21. PQ is my X, that's what I need. So when I write down PQ plus QR equals 20, oops, not 21 yet, equals PR, now I know where to substitute. What's PQ? X. QR is 17 and PR is 28. So now I know that X is 4, which is the same thing as PQ. By writing this sentence, it just clarifies, oops, that's not what I'm trying to do. It just clarifies what we're looking for and how to substitute. Most of what we do this year is a review of all the other things that you've done in your high school career and math career. It's just adding algebra and combining different pieces together. All right. So now we're going to throw in some algebra. You're going to hear me say many times to answer the question being asked. This, for number 3, is the question being asked. What am I looking for? What does it say? Find the value of x. Sometimes if you look at number 3 or number 4, what does it want me to find? TU, which is this whole thing. So sometimes you find x, sometimes you substitute back in. It just depends. So the first thing we're going to do is write our equation. EF plus FG equals EG. That took each of those two pieces and made it equal to the longest segment, EG. Now we're going to substitute. EF is right here, so that's where I'm going to put that. So that's 8x minus 17. And then FG goes right here. So that's plus 5x minus 3 equals, how do I know what EG is? It's in the question that EG is 71. You could, just for clarity, do this so that you know that the whole thing is 71. Now it's an equation. We go through, don't call me after midnight, distribute, combine like terms, move our variable, add, subtract, multiply, divide. So the first thing is I need to combine like terms. Those little squiggles that I did in lines are a visual cue for me. Those are the terms that I'm going to put together. So 8x and 5x is 13x, and minus 7 and minus 3 is minus 20. So we combine like terms. There was no distributing. Now, do I need to move an x? No, there's no x on the other side. So now we're going to add and divide, which is the opposite. So we add 20 to both sides. So I get 13x equals 91. So I've done this one, and so now I need to do the opposite of this. So we divide by 13. So that x is 7. So now I'm done. This is really the only part that's new. Because the second step, the 8x minus 17 plus 5x minus 3 equals 71, that's a multi-step equation that you've been doing at least last year and probably some of 8th grade. So not too bad. Let's look at number 5. This time, I ask you to find JL. That means I'm going to need to find X first, because JL is the whole thing. And so I'm going to need to substitute that back in. So I need to go from that step first. So first we say JK plus KL equals JL. JK is what? JK is what's the value for JK?
27.
27. And KL? 3x minus 1. And then JL, that's up here, is 5x plus 2. I don't need to distribute, but I do have to combine some like terms. Is that 28 or 26? If I combine 27 and negative 1, is that 28 or 26?
26.
It's 26. I have some students that try to do this. You can't use the opposite operation on the same side of the equation. So when you're putting things together, you can't do what I just wrote down, so don't do that. So this becomes 26 plus 3x equals 5x plus 2. I like to move my x's to the left. It doesn't matter. Much better.
Yeah, much better.
You don't have a red nose. Even though it's going to be negative for a minute, I'd rather that. So I'm going to subtract 5x. We did this, and now we're doing this. Oops. Minus 5x. Please carry the x with you. You are unlikely to make a mistake if you make sure that the x goes with you. So this is 26 minus 2x equals 2. I'm going to send your mom a bill for my tissue, Gianni. All right. Now what? Now we've got to add or subtract. So I'm going to subtract 26 from both sides. Negative 2x equals negative 24. Divide by negative 2. X is 12. Now, we're not done because that doesn't tell me what I ask you to find. I ask you to find JL. So if JL is 5x plus 2, that's 5 times 12 plus 2, that's 62. So this is the answer that you need to give me. If you stop at that 12, you might get partial credit, but not full credit. What's the difference between number 5 and number 7? There isn't one. All the expressions have x's. That's not a big deal. You can combine like terms. The only difference really is that I ask you to find all of the terms. So you have to just substitute back in. So once you find x, then you're going to need to substitute that in to find those 3 sides. Okay? Again, make sure you answer the question that's asked. This time it's to find the value of each. When we were talking about midpoint and bisector on Thursday, we covered this material. I'm just going to go over it again before we do a couple of examples. So, the midpoint of a segment divides it into two equal parts. Does it say parts or segments? I'm trying to be consistent in my notes. Segments, I guess. We'll call it segments. Two equal segments. Remember that midpoint has a thing. So we use the word middle all the time. And we probably don't use it the way that we do in math. So, I'm the middle child. I have the middle classroom. I'm the one in the middle of the group. Like those kind of things. We're talking about photos. In math, middle means exactly that. Halfway between each side. It has to be specific. And so when we say that in math, it gives you a hint about what things are equal, how they're equal, those kind of things. So make sure that you use those words and you understand what they mean in a math context. So a ray, a line, or a segment that intersects a segment at its midpoint is said to bisect. We talked about this last week. Bisect the segment, and it's called the segment bisector. Remember that OR and ER just means one who. So a bisector is something that bisects. A teacher is something that teaches. An actor is something that acts. So you just take, it just means that it does what the first part of the word is. So when you look at the diagram to the left, what do these little lines mean? These lines are how we say that this piece is congruent to this piece. It's how we mark them congruent. Remember that these are points. It's a segment because it stops and starts. This is a line because it has arrows on each side. Notice that these are capital and this is lowercase. If we name a line with only one letter, it is lowercase and italics. So you'll see me write it like as a cursive L like that. Those are the same thing. So it has to be we call that line L. So in the diagram to the left, B is the midpoint of AC. Oops, there's no things there. AC, and line L is a segment bisector of AC. Now again, with words that are important, bisector just means it cuts it into two equal pieces. So when you look at number 8, for all the other the problems that we did on this page so far, you had to have 3 pieces of information. You had to have each of the small pieces and then the total for that segment. This time I only give you 2 expressions because of this word. Because I tell you that it's the midpoint, what does that mean that I do with 7x minus 16 and 4x plus 2? What goes in the middle? If Q is the midpoint, what does that mean that PQ and QR, what is their relationship? They are congruent. So as soon as I can write that, then I can write equal. This word is what allows me to say this. On all the other ones, I take the 2 small pieces and make it equal to the sum, to the total of the long line. When it says midpoint, I don't have to do that. So let's go ahead. We do our don't call me after midnight, so I don't have to combine like terms. I don't have to distribute, but I do need to move my variables. So I'm going to subtract 4x from both sides. 3x minus 16 equals 2. Add 16 to both sides. 3x is 18. X is 9. So it's this word that lets me set my equation up. As soon as you know that, then you know how to proceed. So much of what we do this year is based on that type of vocabulary. As soon as I tell you that two lines or two angles have a certain relationship, you will know whether they are congruent or equal each other automatically if you understand the vocabulary. When I tell you that I'm looking for the sine of a number, which when we get to trig, I want the sine of 38 degrees, you'll know how to find that once you understand what sine is. So it's the vocabulary that tells us the steps we need to take. Let's look at number 11, because number 11 is kind of a level 4, getting to level 4 thinking. Because I'm asking you to find y, but there's no y in that diagram. So what do I know? Well, I can start labeling things if it makes me feel better. I can say that this whole thing is 6y minus 2. But I can't put those together because if I write 4x plus 3 plus 7x minus 12 equals 6y minus 2, we don't have the tools to sign an equation, to solve an equation with two variables. I can't do that. So what else do I know? This word tells me that this piece equals this piece. All right, let's see if that gets us somewhere. So then we do 4x plus 3 equals 7x minus 12. Minus 7x from both sides. 3x plus 3 equals negative 12. Sorry, that's negative 3x. Subtract 3 from both sides. Negative 3x equals negative 15. X equals 5. Okay, well, I know what x is now. So how does that get me to the next section? Okay, well, if x is 5, then I can say that this piece, 4 times 5 plus 3 equals 23. So that means that this is 23. So then, right in, what's this? If this is 23, what's this piece? It's also 23 because I know they're the same, because of the midpoint word. So those are 23. So then what does the whole thing equal then? So that means FH equals 46. But FH also equals 6y minus 2. So now I can add 2 to both sides. I shouldn't be able to hear anybody's speakers because you shouldn't have them in your ears, turned on, or in use. Equals 6y, and then we divide by 6. The tension's going to be full this week. Divided by 8. So that's how we get there.